Hello everyone, I'm going to go over the problem on chapters 14 and 15 that's in the review sheet for the next test, for test 2. So I'm going to do this in parts because it has a long series of questions associated with the problem. All right, but let's go over what the question is about. It's study time and score. An instructor at Arizona State University asked a random sample of 8 students to record their study times in a beginning calculus class. She then made a table for total hours X studied over 2 weeks and test score Y at the end of the 2 weeks. Here are the results. So what we've been given here is values for X, which represents hours of study over 2 weeks, right? So it represents, just a second. So hours of study. And Y represents test scores at the end of 2 weeks. So Y test scores. All right. So X, keep in mind that X represents the independent variable, also called the predictor variable, and Y represents the dependent variable, which is also known as the response variable. All right. So we have to come up with a regression equation using both defining and computing formula. And I will just explain the workings here. We are first going to use the defining formula to come with the regression equation. And then with the computing formula as well, we should get the same equation. So here is our actual data, the different values for X and the different values of Y. So 10, 92. So when somebody studied 10 hours in 2 weeks, for the test, the score was 92. Another person studied 15 hours over 2 weeks, the score was 81. Another person 12 hours, 84, 20 hours, 74, 8 hours, 85. And that's how it's going, all right, with the data, or how to interpret the data. Now, to use the defining formula, we have to work through the table. And the defining formula has to take into account these quantities. S sub xx. S sub xx represents how each individual x value differs from the overall mean of x values. S sub xy is the joint variation of the x values and the y values from their respective means. And then S sub yy is how much the y values are off from the mean of the y values, how much the individual y values are off from. And then, of course, we have to square and sum them up. So we are going to use these quantities to come up with the regression equation. So for the regression equation, remember what it was the regression equation form. It was y, let me use another color here, y hat equals b sub 0 plus b sub 1 x. So b sub 0 is going to be our y-intercept, and b sub 1 is going to be the slope. Okay, and here's the formula to find the slope. It's s sub xy divided by s sub xx. And for the b sub 0, it's 1 divided by n times sigma y sub I minus b sub 1, which is the slope, times sigma x sub I. All right, so, or you can use this formula also. It's just a transformation from, it's a transformation of each other. Let's put it that way. All right, so to come up with S sub xx and all that, we have to perform this part of the calculation through a table. All right, so what I have here is, in the table the columns are x, y, and then the next column is x minus x bar, y minus y bar. In the subsequent column it's x minus x bar times y minus y bar. Then we have x minus x bar squared and y minus y bar squared. So in the first column, just have to list all the x values given to you. In the second column, list all the y values given to you. All right, so in the first two columns, we are just copying whatever was given to us. Now, the third column is x minus x bar. So we have to find x bar, which is the mean of all these x values. So the formula to find x bar would be sigma x over n, correct? So we do need to sum up all the x values, and we got a value of 117. So it's going to be 117, and n is the number of values given to us. So it's a random sample of 8 students, so n is 8, right? N is 8. And when we do the division, we should get 14.625. So x bar is going to be 14.625. All right. We have to do the same thing to find the y bar. So again, it's going to be sigma y divided by n. This time you have to sum up all the y values in the second column, and the total was 660. So let's write 660 divided by n is still 8. So y bar is 82.50. So now that we have our x bar and y bar values, we have to take each x value and from it subtract 14.625, which is the x bar value. So 10 minus 14.625 is negative 4.63. 15 minus 14.625 is 0.37. So that's how you go about calculating all the values in the third column, x minus x bar, right? And then you have to do the same thing with the y value. So y minus y bar 82.5. So 92 minus 82.5 is 9.5. 81 minus 82.5, negative 1.5. Right, so in that way we calculate all the values in the fourth column to get y minus y bar. Now in this column, in the fifth column, we multiply the two previous columns, x minus x bar times y minus y bar. All right, so that's what we've done. Minus 4.63 times 9.5 is negative 43.985. 0.37 times negative 1.5 is negative 0.555, and so on. So in this column, we are just multiplying x minus x bar and y minus y bar, because that's going to give us eventually s sub x y that we will need in our equation to find the slope. All right. And then in this last but one column, x minus x bar squared, we have to square all our values in the third column, which is x minus x bar. So negative 4.63 squared is 21.437. 0.37 squared is 0.137. And once we have all these values squared, again, make sure you do not write a negative value in this column. When we square any value, positive or negative, it should give us a positive value, all right? So these are the sums, 157.875. These are the squared differences between individual x value and the mean of all the x values. And we do the same thing with the y value. So y minus y bar squared, 9.5 squared is 90.25. Negative 1.5 squared, 2.25, and so on. So we sum up all these values, and once we have these values, so what I'm going to do is, this represents our sigma x, this is our sigma y, then we have sigma x minus x bar times y minus y bar. And what was this? This was sigma x minus x bar squared, which is going to be used to find s sub xx. And then we have sigma y minus y bar squared. All right. So now that we have these values calculated through the table, we will just use the last row values for to find the equations. All right. So just find s sub xx. S sub xx is sigma x sub I minus x bar squared. That's the formula. Again, these formulas will be given to you in your formula sheet or on your test on the question paper. So 157.875. At this point, there's nothing to plug into the equation. You've done all the work on the table. All right, so just pick up the value from the last row, 157.875, and that's what you write down here. S sub xy, you have to pick up this value here from the fifth column, the last row, negative 133.5. All right, so that's the value you're going to just copy and write for s sub xy. This is the formula, but we did all the calculations on the table previously before. All right, then we have s sub yy, which is the sum total of the last column here, 188. All right, so we just write the values from the table. Now we go to find the value for the slope b sub 1. We first have to find the slope and then find the y-intercept, all right, because we need the value of the slope to find the intercept. Now, s sub xy divided by s sub xx. Now that we have all our values listed up here, just take your values and plug them into the formula. So s sub xy was negative 133.5. That's what we have here. And s sub xx is the one up here, 157.875. All right, so 157.875, it gives us the slope value of negative 0.8456. All right, sorry, negative 0.8456. If that's what it is. I don't know if I misspoke earlier, but it's negative 0.8456, and that's the value of the slope. Now we have to find the value of the y-intercept using one of these formulas. Now I worked it out using both the formula. One is y bar minus b sub 1 times x bar. Doing that, I got a b sub 0 value, y-intercept value of 94.8669. So you can just follow along what we did here. And then on this side, on the right-hand side, I used the other formula given to us, 1 divided by n. So n was 8, so 1 divided by 8. And then sigma y was the sum of all the y values that we used to find y bar. So 660, that's where the value comes from. And then b sub 1 is the value of the slope that we just found. It's negative 0.8456. So we'll have negative of negative 0.8456 times sigma x is the sum of all the x values that we found by adding the first column, the values in the first column. And when you do the calculations, you get the same value for the y-intercept as with the other formula, 94.8669. So you can use either of these formulas, whichever you feel like, whichever you find easier, but either way you should get the same answer. All right, and then here it says write the regression equation. So just plug in the values of the intercept first, 94.8669 minus 0.8456x. All right, it's plus times minus, so we have a minus here. So what we see, what does this formula tell us? The slope is negative. That means x and y are inversely related, right? As x increases, y seems to be decreasing, right? That's what the equation is telling us. So now we will do the same calculation using the computing formula, and we should come up with the same values for b sub 0, b sub 1, and therefore the same regression equation. Now we are going to work the same problem using the computing formula, but as you will see, the computing formula is supposed to be faster and more efficient, and you will note already by looking at the table that we have fewer columns than we had using the defining formula. All right, we just have 4 columns versus 7 columns. So over here, all right, for the computing formula, let's just first visit the formulas for the slope and for the intercept. The slope is s sub xy divided by s sub xx, which is the same as what we used for the defining formula. However, to calculate s sub xy, the formula we'll be using is sigma x sub I times y sub I minus sigma x, and then this one is actually sigma y sub I. So let me just insert that somewhere here. All right, this should be, just a second, erase this, and there should be a sigma, all right, with y. It should be sigma y sub I divided by n over sigma x squared minus sigma x whole squared divided by n. All right, so that's the formula we are going to use. Now it looks more complicated, the formula itself, from the defining formula that we used for s sub xy divided by s sub xx. However, in order to find s sub xy using the defining formula, we had to use 7 columns, whereas here we'll just work with 2 extra columns. All right, 4 columns altogether. So in the first 2 columns, we just list the values of x and y, and then we have a column which is x multiplied by y. So we are going to just multiply x and y and write them down here, and at the end sum it up. So sigma x sub I, sigma xy, x sub I times y sub I is what is going to go into the first term of the numerator. And then in the last column, we just square our x values. So all the x values are squared. So let's just quickly go over it. So we have 4 columns, x, y, x multiplied by y, and x squared. So again, x and y are just values the values that were given to us, which we just listed in this table. And then x times y is multiply 10 times 92, 920. 15 times 81, 1215, 12 times 84, 1008, and so on. All right, and then for the last column, you just square all your x values. So 10 squared is 100, 15 squared is 225, 12 squared 144, and so on. And at the end, we have to sum all these columns here. So sigma x is 117, sigma y was 660, which we got when we used the defining formula as well. Then sigma x times y is the sum of all the values in the third column, x times y, 9,519. And then the last column summed up is sigma x squared, which is 1869. Again, always make sure or double check that you've added these values correctly, because if you miss one value, you will get a wrong value for the sum total, and that will mess up your entire work below. All right, you'll end up getting a wrong value for the slope, a wrong value for the intercept, because this whole equation works with these values in the last row, the total of all these columns. All right. So now that we have now we just need to look at this last column. All right, we don't need the values, the individual values in the table. We just look at the total column, the total. So the first term in the numerator is sigma x times y, and that's 9519, correct? So 9519. And then minus sigma x. So sigma x is 117, the sum total of all the x values. So I have 117. And then sigma y is the sum total of all the y values, 660. I have 660 divided by n. Divided by n is 8. So I have 8 there. And then in the denominator, we have sigma x squared, which is the value in the last column, the total value of the last column, 1869, minus sigma x whole squared is 117, is the sum of all the x values. So 117 whole squared divided by n. So that's actually, let me just erase this and write 8. That's 8, correct? And make sure you again punch in the right values in the proper order of operations in your calculator. All right, this should be calculated first, and then the value, the result of this here should use a different color. All right, so this multiplication division comes before addition and subtraction. So you have to calculate the value of the second expression first in the numerator and then subtract it from 9519. And same thing over here, 117 squared divided by 8 should be calculated first, and that result should be subtracted from 1869. And when we do this calculation, we get a b sub 1 value of negative 0.8456, which matches with what we got using the defining formula. For b sub 0, we will use this formula again, 1 divided by 8 times 660, which is sigma y, minus 0.8456 times 117, which is sigma x. All right, and then we get a b sub 0 value of 94.8669. All right, so this is the computing formula to use, right? Because we are not having to find x bar and y bar using the computing formula, right? It's better not to use the y bar and x bar, the formula with y bar and x bar in it, because you will have to again calculate the mean of the y values and mean of the x values, which is not difficult since you have the sum total of x and sum total of y anyway, but you don't need to. All right, you can just right away use the computing formula and get the same answer, 94.8669, and then just plug in the values of b sub 0, the y-intercept, and that of the slope into the regression equation form. So you get y equals, y hat equals, really, because this is a sample regression equation. All right. So this is how you're going to work through the first sections of the questions on the test as well. All right. The following questions here are based on the calculations, the equations that we came up with in part 1. It says, how do the regression equations compare using the defining and computing formula? They are the same equation, right? They give the same values for b sub 0 and b sub 1 for the intercept and the slope, and therefore they provide the same equations would be your answer. Describe the parent relationship between the two variables under consideration. So based on the equation, you just have to say the exam scores decrease on average about 0.85 points for each hour of study time. So you have to be specific and relate the relationship to the equation that you came up with. We saw that we had a negative slope, therefore the scores are decreasing as the hours of study are increasing. So you have to answer this question in context of the problem and the equation related to it. Number 4 says, interpret the slope of the regression line. The exam scores tend to decrease on average about 0.85 points for each hour of study time, which is the same as what we said above in number 3. They essentially are the same thing. The relationship between the two variables are determined, or rather is determined by the slope of the regression line. Therefore, they have the same answer pretty much, right? Now, just a second. Let me just move up a little bit. Identify the predictor and the response variable. So which one is the predictor variable here? The x variable, which represents the study time. Again, you need to answer this in context of the question. And response variable is the y values. So that's the exam score. All right. What else? Identify the outliers. I don't think there were any outliers as such, but 8,85 and 10,92 could be considered as potential. All right, so it's always good to use the word potential because we don't know exactly if they are outliers or not. So could be, but it's possible that they aren't outliers either. All right, and then it says number 7, predict the score of a student who studies for 15 hours. So all you have to do is bring your equation here, which is, what was it? It was y hat equals 94.86698 minus 0.8456x times x. So you have to plug in the value 15 into x and calculate the expression, which should give you your score. So we got a score of 82.18. All right, it doesn't make much sense really, because what this equation is saying that if somebody doesn't study at all, he begins with a score of 94.8. So somebody who puts in 0 hours of study scores 94, almost 95%, and then as the hours increase, it the scores decrease by 0.85, right? So tells that it's not just the hours of study, but a lot more that's involved in determining the score. All right. But since we are just studying single independent variable, we leave it at that. All right, we won't complicate this any further. Now, for number 8, it says compute the 3 sum of squares SST, SSR, and SSE, and find the coefficient of determination using the defining formulas. Now, I'm not going to solve this. Part of the work has already been done when we were working on the defining formula to come up with the regression equation. For this one, you will of course need to calculate your predicted y value that comes from the equation. So you'll have to plug in all these x values one by one into the equation that you got previously, right? This equation, come up with the y hat values, and then go through this table column by column. Y hat value we already calculated when we were coming up with the regression equation, and it's just the y hat values that you need here, and then go through the process. So I'm going to skip this. You can do it yourself because I'm going to go over to working this out, finding the coefficient of determination using the computing formula, and the answer end result should be the same whether you're using the defining formula or the computing formula. Now on the test, you don't have to, well, I won't even ask you to use the defining formula. It's going to be very time consuming, so you will be using the computing formula on the test, and when you do that, you will be reusing the same values for the most part from the previous calculations you did for your regression equation. All right, so in order to find the three sum of squares and subsequently the coefficient of determination using the computing formula, these are the values we will need: x, y columns, which are given, right? These values are given. X times y. Now this has already been calculated up there. You can look up the table. X squared value was also calculated for the regression equation. What was not calculated was the y squared values. All right, y squared values is the new column that we have here. So again, all you do is square up all the y values, write them, list them down, list them in the last column, and sum it up. All right, and now we are going to use just the end sum total row at the bottom in order to work through these formulas. All right, so SST is equivalent of S sub YY. All right, so, and that the computing formula for that is sigma y squared minus sigma y whole squared divided by n. So sigma y squared, that's the reason we needed this last column. We needed to find sigma y squared. 54638 minus sigma y is 660 whole squared divided by 8. All right, make sure this slash sign is division, it's not multiplication. If you wish, write it a little bit at the lower level. All right, and do the calculation. All right, so SST after this calculation is 188. Right? Okay, so 188. Make sure you first calculate this squaring and division, and then subtract the result from 54638. All right, the order of operations is very important. Otherwise, you'll get a completely different answer. First squaring, then division, multiplication, and all that, and then lastly it's addition and subtraction. SST. So we got a value for SST. Then SSR. So SSR is sigma x times y minus sigma x times sigma y divided by n, and the whole thing is squared. for the numerator, and for the denominator it's s sub xx. So that means sigma x squared minus sigma x whole squared divided by n. Now this value here again was calculated when we were working on the regression equation. Now this part, all right, for SSR was also calculated, but it was not squared, right? So we can plug in the value. Sigma x times y is this 9519. Sigma x is 117, so we have 117 here. Sigma y is 660, we have a 660 here, divided by n, and then the whole numerator is squared. And then for the denominator, we have 1869 minus 117 whole square divided by 8 for a SSR value of 112.89. All right, so that's our SSR. Now that we have SSR and SST, SSE should be easy. All right, please don't try to use this formula. If you know SST and SSR, just subtract SSR from SST to get the value of SSE, and that's 75.11. And for the coefficient of determination, what's the formula for that? It's R squared equals SSR divided by SST. All right, so just plug in your value for 112 for SSR, which is 112.89, divided by 188 should give you your R squared value, which is, we've done it here, 0.6005. All right, so here is the place where we perform the calculation. Please write the formula. This is an easy formula. I shouldn't have to give it to you. It'll be there on the formula sheet. All right, if you don't remember, look it up on the formula sheet. Okay, so our coefficient of determination is 0.6005, but what does it mean? All right, so let's see. Let me just erase these. All right, so the question here says determine the percentage of variation in the observed values of the response variable that is explained by the regression. All right, so all you need to do is interpret the coefficient of determination, and it says percentage, so you have to convert 0.6005 to percentage form, multiplying by 100. So the percentage of variation in the observed y values, I'm just using the wording in the question, the percentage of variation in the observed values of the response variable that is explained by the regression is 60.05%. It's 0.6005 converted to percentage of the variation in the score data. Data is explained, right, by time, by the time, or by the hours, really is a better way of putting it. Is explained by the hours, or you can say by the regression. Number 11, state how useful the regression equation appears to be for making predictions. It's moderately useful, right? It's 60.05% or 0.6005. So we can say it's somewhat useful, moderately useful for making predictions. Remember, the closer it is to 1, the more useful it is for making predictions. That's how it goes. All right, so finding R using the computing formula. So now we are going to go on to finding the linear correlation coefficient, which is R. All right, it's R without the square. All right, so that's what the linear correlation coefficient is. Now, I've worked it out using the defining formula again for the test. All right, you are going to use the computing formula. all right, because this is too much. You won't have time to work everything using the defining formula, but I've worked it out here anyway. So if you want to see how it's been worked using the defining formula, just pause the recording here and or video here and pick up the values, check your answer against mine, and see how the calculations were done here. You need your S sub x, S sub y, and then this is the defining formula for the correlation coefficient. All right, but using the computing formula, this is what the computing formula is. So you do not need to again work through a table. You already have the calculations done previously. So please just go back to the table and pick up the values and write it, because you won't have time to start working through a table all over again. All right. Now, sigma x times y minus sigma x times sigma y divided by n was the numerator, or is the numerator or in the formula, divided by square root over sigma x squared minus sigma x whole squared divided by n. So this was already calculated really for the correlation coefficient, as well as sigma y squared minus sigma y whole squared divided by n. So somewhere up there, all these calculations were done in bits and parts. All right. So just make sure that you note those values so you can reuse them. You do not need to recalculate everything. Just plug in those values before. For example, the numerator here, sigma xy minus sigma x divided by n, sigma x times sigma y divided by n was done, let's see, it was done probably, see over here, when we were finding SSR, we had sigma xy minus sigma x times sigma y divided by n. Only thing is, for SSR, we squared it, but if you have this value noted down when you were doing this calculation, then you can just reuse it for your R calculation. All right, for correlation coefficient calculation. All right, so we plug in the values. 9519 was sigma x times y minus 117 times 660 divided by 8. And then for the denominator, it's sigma x squared was 1869. Sigma x whole square divided by n is 117 squared divided by 8. Now this calculation was done. I'm hoping you will calculate, keep a record, keep a note of these intermediate calculations and use the values. All right. So once you plug in all the values and perform the calculation, we get an R value of negative 0.7749. That's our R value. Okay, so now we have to interpret the value of R in terms of the linear relationship between the two variables in question. So the value of R suggests a strong negative linear correlation between study time and score for calculus students. All right, but one thing, this is a negative value, so that means that's why we have to say it's negatively correlated, and based on our sample data, it shows a strong negative linear correlation. All right. Now, whether it is appropriate, whether the regression equation is appropriate, or let me rephrase it, whether the sample regression equation is appropriate to predict all other for all population data, that is questionable, and that will be determined from the inferential studies. We are still working on the descriptive part of the regression analysis based on actual data. Number 15 says square R and compare the result with the value of the coefficient of determination you obtained in previous question. So R squared equals minus 0.7749 whole squared. So R squared, just square your coefficient value, correlation coefficient value, and see if that matches with what you got for the coefficient of determination. This matches the coefficient of determination calculated previously. All right, so this completes all the questions that you may need to answer on the test on chapter 14. Now, for chapter 15, we will have to go into the inferential part, or we go into the inferential part of regression equations and regression and correlation. So that's what we will cover next. All right, these few questions here.